Today we'll go through chapter 14, which is on JIT, which is just in time, and lean operations. The main concept behind lean operations is that how to use minimum resources to achieve high productivity, low cost, and higher quality, and things like that. Actually, lean operations was pioneered by Ono and Shigeo Shingo. So Taichi Ono was the founder of Toyota Motor Company, and lean operation basically brings a lot of new ideas and concepts from Toyota Motor Company, the applications they have made and best practices. And Shigeo Shingo also has contributed a lot towards this. Now, the interest in lean operations in US started in early 90s, and in fact, there was a book called The Machine That Changed the World. So this book was written by Womack back in 1990, and this started a lot of interest in lean operations. So we'll go through lean operation system, the very basics. Then what are the different goals of just-in-time concept? So lean and just-in-time are used synonymously. Building blocks of JIT, and what are the benefits and obstacles? Now, just-in-time has been defined as a highly coordinated processing system in which goods move through the system and services are performed just as they are needed. So there is nothing more or nothing less. So everything is brought in as and when it is needed. So in a way, in a manufacturing company, for example, people are not carrying inventories around to manage or to balance the things. So as and when something is needed, then it gets created. So we'll look at more details. And the concept of just-in-time or lean production, you can use them in the same sense. So just-in-time, or JIT as it is called, is based on a pull system instead of a push system. So what happens in push system is that something produced on one machine or at one operation gets pushed to the next operation or next machine. So that product may need that processing. So opposite of that is pull. So it comes from the demand from the customer. So when there is a demand for something, then an operation will contact the previous operation to make those items. So JIT operates with very little fat. So fat meaning inventory. So we do not need a lot of inventory when operating using just-in-time. So inventory is always a waste of money. It is not adding any value. In fact, it incurs inventory carrying costs. So all those things increase the cost. Now, goals of JIT are basically to have a balanced system that achieves rapid flow of material through the system. We had actually talked about how to balance systems using the cycle time in previous chapters. So the idea here is how to make it happen throughout the company to achieve smooth, rapid flow of material. And supporting goals are eliminate disruptions, because disruptions cause a lot of problems in manufacturing or service activities. So the idea is to eliminate disruption so that things can move smoothly. Now, disruptions can happen because of so many different reasons. So for example, if the processes are not balanced, then it may cause disruption or problems. Inventory may build up to such an extent that it hampers work. Disruption also can occur because of maybe machine breakdowns or maybe skill levels of people. So all that is attacked and people try to eliminate them under JIT. Another goal is to make system flexible. So flexible means it is robust to handle mix of products. So if there are different requirements at different time, then the system has to be flexible enough to meet those requirements as and when they come. The next one is eliminate waste, especially excess inventory. So you can see here, excess inventory is treated as a waste. So remember that excess inventory doesn't add value. It does not add value to any process. It only adds cost. So if you look at summary of just-in-time concept in this picture here, the ultimate goal is to achieve a balanced, rapid flow. And then the supporting goals, those three goals we looked at was to eliminate disruption, make the system flexible, and eliminate waste, which can come from different sources. And how to achieve these things? There are 4 building blocks: product design, process design, personal elements, manufacturing, planning. So all these things are building blocks. In fact, we'll look into more details of each one of them. Coming to what are some other type of wastes, so they are listed here. Apart from inventory, overproduction also is a waste. It adds to the cost. Waiting is waste or non-value adding activity. So by waste I mean non-value adding activities. Unnecessary transportation is waste. Like it can happen when the layout is not very good and material has to move from location A to B in a longer route, then obviously it is unnecessary. So if the layout can be improved such that the distance between A to B can be minimized, that will eliminate a lot of unnecessary transportation of material. Because once the transportation increases, the chances of things getting damaged also increases. Handling increases. So that is a waste. Processing waste could be like when a worker is trying to get the machine started, so there could be 1 or 2 items he or she has to try with, and that may go as a waste. So there could be some processing waste. Then inefficient work methods also is a waste, and product defects, obviously they add cost, they do not add any value. Now for eliminating waste in lean operations or just in time, people use what is called as Kaizen philosophy. So under this philosophy, the first one is waste is the enemy. So waste or non-value adding activity is the enemy number 1 for any organization, because that depletes its resources and activities going to non-value adding activities, and it all increases cost. Gradual and continuous improvement. So that is the second principle used in Kaizen, or philosophy used in Kaizen. So people are looking at actually small and incremental improvements and not a breakthrough improvement. The reason is that more and more people can be involved, as you can see the next point, when a team attempts to make improvements. So like even workers who are working on the machines and the related areas, they can be involved in making these kind of improvements. So next one is built on a cheap strategy. So it's not that people are trying to achieve improvements which are very expensive. They start with something which can be done at a very low cost. Another philosophy is that it can be applied anywhere. We'll see that many of the concepts are very general in nature. Many of them are like common sense kind of approaches. So it can be applied anywhere. It can be applied not only in a company, but also maybe at your home, supported by a visual system. So visual system means these systems are visible to everyone in the company. So if any problem occurs, everybody can come to know about it. In fact, there are certain lights, like if a defect starts getting created at a machine, a red light will glow, and even somebody far away from the machine will know that there is some problem there, and they will run there and try to correct the problem. There are like designated areas with red paint and green paint. So for good and bad items. So anybody who goes red paint, they know that all those items are rejected items. And in the green area, they have all the good items. Focuses attention where value is created. People focus into that area where the value is being created, not in other areas. So if there are such areas like non-value adding activities and people have to waste their time in that, then obviously overall company will suffer. Kaizen philosophy is process oriented. So traditionally what had been happening was that if there is a problem, then somebody is held accountable. So that person is found out who made the mistake and then fire that person. So under Kaizen philosophy, people believe that any problem or mistake is not fault of the people, but it is fault of the process. So they try to improve the process instead of firing a person to solve the problem. So this is process oriented and not people oriented. Improvement should come from new thinking and work style. So there is a book by Stephen Covey. So at one point he made a statement that from the same roots you get the same fruits. So if you want to change the fruits, you need to change the roots. By doing the same thing, obviously, you get the same results. So improvements will come from new thinking. So one has to find new ways of doing things, and that will only lead to improvement. Learn while doing. So all these are part of Kaizen philosophy. There are two types of just-in-time applications. One is big JIT and other is little JIT. So big JIT has a broad focus, like you are also looking at vendor relations, so not within the company, but also you go out and look for improvements at your suppliers. It can involve human relations, technology management, materials and inventory management. So all those things which are outside the immediate manufacturing or related operation. Little JIT has a narrow focus, so this goes into more details within a small area. So you could be looking at scheduling materials, scheduling services of production, and so on. We'll go through these 4 building blocks one by one, starting with product design. So this you can say is the first building block. So within product design, under the concept of JIT, companies use standard parts. So we had talked about this earlier also. There are a lot of benefits in using standard parts. One benefit is that workers have to deal with few parts, and that basically in turn helps in training people, so people can be trained easily. Purchase becomes easier, handling quality also is easier with standard parts. If you go to modular design, so modular design is a bit of extension of standard parts. So it includes more than a part. Like within the engine of a car, like there are different modules. So the idea is same, that once you have modular designs, the workers again will have less and less items to work with, and training becomes easier and things like that. Highly capable production system. So obviously it needs highly capable production system. So capability relates to, let's say a product design for a certain item is like this. So this is the lower limit and this is the upper limit. When somebody is processing a product or component within a company at a particular operation which has these lower and upper limits, so when they start manufacturing, and if the data is collected and if it is plotted and if it looks like this, so this is a normal distribution, so variability of that quality characteristic is you can see well within the requirements. So this process is called capable. By capable, it means that it is capable of meeting the requirements. Whereas under same scenario, if you have these requirements and if we collect data and the variability, if it is much beyond, so obviously there will be a lot of items which get rejected. So obviously this process is not capable of meeting the requirements. At product design stage itself, in lean manufacturing, people focus on highly capable production system. The next one is concurrent engineering. So most of the problems occur when people down the line are not involved at the beginning. So while designing itself, if we involve people from manufacturing and other areas and understand what capabilities they have while designing, if those information can be baked into the product design, then obviously later on there will be a lot less difficulties. Now the second building block is process design. So this is number 2. So there are so many elements like small lot sizes, setup time reduction, and so on. So we'll look at each one of them one by one, starting with small lot sizes. In lean operations or just-in-time concept, you can say the ideal lot size equals just 1 unit. So the idea is to have as low inventory. In fact, if there is no inventory, that's the best situation. So benefits of small lot sizes are it reduces inventory. So by lot size, what it means is, let's say we have a particular operation, some cutting operation. So at the cutting operation, you have a cutting machine, and so obviously before the process starts, a worker will have to make some adjustments in the machine. They may have to load a new tool for the dimension, how much to cut. They have to make some setting changes. So how many items they produce once they have made these setting changes, so that's the lot size. So maybe lot size could be once those settings have been set on the machine, and if they plan to produce 1000 items, then lot size is 1000. Then they may take up a new product with a new dimension and accordingly make some changes in the machine and produce maybe another 1000 items. So the whole idea is, if the lot size is small, it will lead to less inventory. So instead of 1000, if the lot size is only, let's say, 10, so obviously when it goes from operation 1 to operation 2 to operation 3 and so on, you will see less and less inventory build up. There will be less rework. The reason that there will be less rework is, let's say at operation 1, if they produce only 10 items, then if there is a problem in those 10 items and if they need rework, then they are dealing only with those 10 items. But if the lot size was 1000 and if some rework is required for the entire lot, so 1000 is obviously much more. So if the lot size is less, one good thing is that it might lead to less rework if some problem comes. Because of less inventory, less storage are more apparent. So let's say you produce 10 items at operation 1, and as soon as it goes to operation 2, and if there is any problem, it becomes immediately known. But if you are producing 1000 items at operation 1 and then it moves to operation 2, so one is that for producing 1000 items, more time is needed. So the problem will come to be known at much later time, and it will be too late and too expensive. it increases product flexibility. So if you are making only say 10 items at a time, then you can move to the next item very quickly. So smaller lot sizes means more flexibility, easier to balance operations. So there are so many benefits. Now SMED, which stands for single minute exchange of dies. So this was developed by Shigeo Shingo. These are all Japanese names. So especially in big press shops, which are like in automotive companies, for making say a car door, for example, it needs to be pressed in certain shape. Now that operation needs huge dies. It needs dies which are like very, very heavy. Now to handle these dies, companies have big cranes within the company. So if you have a die like this, and it may be stored one over the other, and suppose you need the bottom die for a particular operation, so first the top dies need to come down. So heavy, all these things happen very, very slowly, and a lot of supervision is needed, a lot of care is needed. One is you don't want to damage the dies, and then because that is going to be very, very expensive. So that slows down the whole process a lot. Like sometimes it could take 8 hours to just change from one die to the other die. So 8 hours is a lot of time, and it brings down the productivity. So Shigeo Shingo came out with a concept, and in fact it was applied successfully, that die exchange time was brought down from 8 hours to single minute. So single minute means it is a single digit. It could be 1, 2 minute, 3 minute, or up to 9 minutes. Anything less than 10 minutes. So the main idea was that you classify all the small activities needed to change the dies into internal and external. So internal activities that can only be done while the machine is stopped, and external are that do not require stopping the machine. So for example, to bring this bottom die near to the machine does not require the machine to be stopped. So this can happen while the machine is running. So people can save time there. So such activities were identified, and if possible, they also tried to move some of the internal activities to external activities, and they achieved single minute exchange of dies. So this is very critical, especially for making lot sizes smaller, because if it is taking 8 hours to change the dies, then the tendency is that the management wants to do as much production as possible once the die is set up. They don't want to make changes too often because it takes a lot of time. But when it is single minute, then obviously things can be done pretty fast. So that can help small lot sizes. Now coming to quality improvement. So in JIT system, they use what is called as automation. So defects are detected automatically during the production. What happens is, as soon as a defect is detected, the machine is stopped, then investigation is done, and then corrective action is taken. So because a main problem in many companies is that they are not able to detect defect early enough. But if it is automatically done, then that will save a lot of time before it is too late. Because if it is not detected early, then if a defect passes from operation 1 to 2, and then from 2 to 3, and then from 3 to 4, people say that the cost of that defect multiplies by 10 as it moves from passes from one operation to the next operation. So it is going to be very, very expensive by the time you detect it here, because lot of time and money has been wasted in the previous operation. So it always makes sense to detect it early. Japanese company, they started using automation. Japanese word for that is judoka. So once you have like single minute exchange of dies and small lot sizes, so it offers lot of production flexibility. We saw like how to reduce downtime by reducing changeover times or machine setup times. For production flexibility, companies also use preventive maintenance rather than breakdown maintenance. So they do not wait till the machine fails and then make repair. Instead of that, they do preventive maintenance. So that is always better than breakdown maintenance. Cross-train workers to help clear bottlenecks. Worker can do like 2 or 3 different types of jobs within area of his or her expertise, then that increases the flexibility. Use many small units of capacity. So that also increases flexibility. Use offline buffers. So small inventory to improve flexibility. Reserve capacity for important customers. So all these go towards helping improve flexibility. So this should be actually balanced system. So this is similar to line balancing we had talked about in earlier chapters. So distributing the workload evenly among workstation. The whole idea is to have demand equal to capacity. So if there is a good match between the two, things will be balanced. If there is a mismatch, obviously it will not be balanced. So in JIT system, work assigned to each workstation must be less than or equal to the cycle time. So we had seen some problems using this, where we can come out with how many workstations are needed given the cycle time and type of operations and how much time each operation will take. So under JIT, cycle time is set equal to what is called as a takt time. So takt time is the cycle time needed to match customer demand for final product. In fact, under JIT, this takt time is called as heartbeat of lean production system. It is depicted very clearly in this picture here. There are big rocks. So these rocks, you can say, are the problems. And this water level, you can say, is the inventory. So when the inventories are high, that means water level is high, all the problems are hidden. But when we reduce the inventory, the problem becomes visible. And once those problems are solved, so those problems are eliminated, you can see in the third picture, much less problems in the form of rocks. So that's what is achieved by attacking inventory, bringing down the inventory. Initially, obviously, it will be very unpleasant, because if you have, let's say, machine 1 or operation 1, 2, and 3, and if we say that we don't want to carry any inventory in between, so this is not allowed. So no inventory is allowed. But after operation 1, those items have to go to operation 2 for the second processing. So if this machine breaks down, there's nothing for 2 or 3 to do. They will be sitting idle. So initially it may look as a disadvantage, but the good thing is, because it will create the shutdown entire line, people will focus all their energies to correct the problem at operation 1. So it will get solved earlier. So coming to the third building block of JIT, personal organizational elements. So under this, workers are treated as assets. They are not treated as liabilities or cost. Cross-trained workers, they add flexibility. Now for continuous improvement, workers are expected to be involved in problem solving efforts. So it makes their job also interesting, and because they know the best, what's wrong in that process, they are the best people to make any improvement suggestions. So in continuous improvement under just-in-time concept, there is a lot more involvement by workers. In fact, there are terms like quality circles, which are very popular in Japan. This group of a team of workers meet periodically and try to make improvements, continuous improvement to their operations. Cost accounting in just-in-time, we use ABC costing. So ABC stands for activity-based costing. And then leadership and project management. So managers are expected to facilitate us. Under this concept, they are not only there to give orders. So that's the major difference between a traditional company and companies implementing lean concepts. The fourth building block is manufacturing planning and control. So level loading, again, it talks about the balance or balancing. So other things, let's look at in more detail in next few slides. So the next one is pull systems or comparison with push system. So in pull, workstation pulls output from the preceding station as needed. And in push, output is pushed to the next station. So if you have like stations like this, so it flows in this direction, whereas in push, you produce something at the first operation and then push it to the next one. Then once they are done, they will push it to the third one and so on. So that's the basic difference between the two. The first one, it originates from the demand, a customer demand, and then goes backward. So people use what is known as Kanban production control system. So Kanban is a card, or it could be some other device that communicates demand for work or material from the preceding station. So this is the methodology they adopt to implement pull system. Kanban is the Japanese word meaning signal. So it is a signal for the previous operation to get started or start producing. Or it is a visual record. So it is a paperless production control system, and authority to pull or produce comes from the downstream process. So they have also come out with a formula that how many Kanban cards in a system they should have to operate efficiently. So under JIT, when we have like limited inventory or limited work in process inventory, there are a lot of benefits. Obviously, low carrying cost because you don't have much inventory. It increases flexibility at each operation because the lot sizes are less and less inventory exists. It aids scheduling. So each operation becomes free much earlier. So because the lot sizes may be small, and that basically helps in scheduling. So different product mix can be scheduled more easily rather than a situation where one machine keeps on producing the same part for entire week. It saves cost of rework and scrap. So two general approaches, Kanban we have seen. So Kanban focuses on individual workstations, and then there is a constant work in process, CONWIP, which focuses on the system as a whole. So not only a particular workstation, but entire system. Now in just-in-time, you can see the comparison. This you can say is just-in-time approach, and this is the traditional approach. So a buyer, let's say, buys several items from a supplier, so many suppliers. In fact, there was a time when a big auto company would have like hundreds of suppliers, and it is very difficult to manage all that. Under JIT concept, they have a tiered system, which is also used nowadays by Ford Motor Company or General Motors. So they have first tier suppliers. So let's say this is an automotive company, and this is a supplier of, let's say, engines. Now Obviously, this supplier of the engine is not making each and every part within the engine. Like an engine could have more than 7,000 parts. So not everything is made by the supplier, but they also depend on their own suppliers. So they could have second tier suppliers, which in turn can have another set of suppliers. So for example, in the engine, there could be a fuel injector for which the supplier could be maybe Cummins. And within the fuel injector, there are so many different parts. So some of that could be supplied by third tier suppliers. Now, the good thing about this is that the major auto company has to look only at or work only with this supplier. Now, it will be the responsibility of this supplier to make sure that their own suppliers, the second tier suppliers, give them the quality products. And similarly, the responsibility goes down for second tier suppliers. They have to make sure that the third tier suppliers provide them with good products. So basically, the burden, you can say, of quality is on the vendor. So that is very, very important, because otherwise this supplier or buyer will be wasting a lot of time and energy in confirming that the product is good quality. So most of the times what this company may do is they will go through their processes, and once they are confident, they will issue a certificate of quality. And when those products come back to them, they are allowed to come in even without any quality inspection, because the burden of quality is on the vendor. So if any problem occurs, the vendor will have to pay for that. So preventive maintenance is maintaining equipment in good condition and replacing parts that have tendency to fail before they actually fail. So we talked about this earlier, and preventive action is always better than like breakdown maintenance. So another thing which helps is housekeeping, 5S. And you can see the list here. So sort means sort out the things, what you need, what you don't need. Straighten is to organize, so organize those things appropriately. Sweep relates to cleaning the area where we work. Then standardize, place for everything, and then keep those tools at their place, so that when the next worker comes in the next shift, they don't have to struggle to locate those tools. And then there has to be self-discipline. So all these things have to be carried out day in and day out. So these things are actually not only useful in companies, but even in our daily life, place where we work, on the table, in the offices. So if we apply these 5 steps on a continuous basis, it will make us a better person and more effective. So if you compare various factors for JIT and traditional system, let's look at inventory. So in traditional systems, people try to keep a lot of inventory, basically to offset forecast errors, because the forecast may not be accurate. So you want to have inventory as a buffer. But under JIT, we try to keep as low as possible. As mentioned earlier, the ideal size for inventory under JIT condition is 1. Deliveries are few and large for traditional system, but many and small for JIT. Lot sizes we have talked about. Under JIT, it is small, whereas it is large for traditional companies. And it is large because it takes a lot of time to set up the machine and the process. Whereas in JIT, we try to use single minute exchange of dies concept to reduce the setup time, and that helps to keep lot sizes small, and it makes us more flexible. In a traditional system, people look at very short-term relation. They want something at a low cost. So long-term relations are unusual. Whereas under JIT concept, there are companies who have actually relation with their suppliers for maybe 20, 30, 40 years. Under traditional system, workers, they are treated like somebody who is necessary to do the work. And when there is a problem, they are fired. But In JIT, they are treated as assets. So they keep on adding value to their abilities by providing them necessary training and developing their skills. So what it takes to transition from a traditional system to JIT system. So obviously one has to have top management commitment because they are the ones who will be providing the resources necessary. Decide which parts need most effort. So obviously those areas where there are more problems, they are the good candidates for implementing JIT system. Obtain support of workers. So ultimately workers are going to be involved on a continuous basis, and for continuous improvement, they are the people who can lead it. So it is important to have their support. It should not look like that it is being thrust by the top management on them and then they end up doing more work. Start by trying to reduce setup time. So that should be the starting point most of the time because that's where most non-value adding activities exist, and that creates a lot of problems down the hill, like bigger lot sizes and then more inventories and then all those costs. So it is always better to start to reduce setup times. Gradually convert operations. So slowly, like it's not like a switch of a button that you switch on, you become JIT, switch off, you become traditional. So it is going to take time. So time has to be given for operations to convert. It is also important to convert suppliers to JIT because they are supplying you the material, raw material, or maybe some parts and components. So if they are not of good quality or if they cannot come in just in time, then obviously this company which gets items from them will suffer. Obviously there will be a lot of obstacles, so one has to be ready with the necessary training and tools. So it's not going to be easy for any company to move from one way of doing things to new way of doing things. And sometimes the obstacles are with the management itself. Management may not be committed. So that will create a lot of problems. In fact, if that's the situation, then the company has to first address that problem. Worker management may not be cooperative. So if a company has a history of like fight between them, then it's not going to be easy. So at least some background work has to be done before a company can think of implementing just-in-time concepts. Difficult to change company culture. So this is like develop over a period of time, and actually the top management of a company has a lot of role to play in that. So it is not something, culture is not something which is developed overnight. It takes a lot of time. So because of that, even changes will take time. And sometimes even one can face resistance from suppliers. Some of those reasons are actually listed on the next slide. They may be unwilling to commit resources. So they may feel at the beginning that, for example, to reduce setup times, there may be more workers needed to do the external activities when the machine is already running, and to do that offline, there may be more workers needed. So the supplier may be unwilling to commit those extra manpower. Uneasy about long-term commitments. So they may have a very short-term goals to make quick profits and things like that. In that case, they will be uneasy about long-term commitments. There could be frequent small deliveries, which will be obviously be difficult for a supplier if they do not understand that in the long run it is going to benefit them. Another important thing is burden of quality shifts to the supplier. So that will mean that may seem to supplier that it will add cost again because they may have to keep more people to make sure that the quality is of desired level. Frequent engineering changes may cause JIT changes. So if there are many changes occurring at a company, supplier may undergo a lot of disturbances because of that. Just in time has a lot of benefits for services also, like obviously it will eliminate disruptions if it can be JIT can be implemented. It will make system more flexible, reduce setup and lead times, eliminate waste, minimize work in progress, simplify the process. All those benefits that a manufacturing company can benefit from by implementing just-in-time concept, even services can benefit. JIT 2 is a supplier representative works right in the company's plant, making sure there is an appropriate supply on hand. All these things which are listed here are also the benefits of JIT 2, and these were also benefits for JIT.